Hi, my name is Pawan. We are going to see the Boolean algebraic function next year in the syllabus. This slide is about my details. Why, why is the Boolean algebraic function? Boolean algebraic function is a branch of algebraic that deals with the variables that have two different values, typically respected as true and false. True is represented as 1, false is represented as 0. It is the fundamental in the fields of mathematics, computer sciences, digital electrons, and logics. Importance of Boolean algebraic form the function of all Boolean operations like and, nor, not, gates used in designing logical computer memory, and the processes. Provides a way to model real-life situations which has no decisions. Boolean algebraic is important because it provides a mathematical framework for reasoning with the binary values 0 and 1. It allows to design a simplification of logical expressions which are the backbone of digital systems, computer sciences, and modern technologies. Basic concepts of Boolean algebraic first function. First one is binary variable. A binary variable can take only two values, 1 and 0. 1 is represented to true, 0 is represented to false. Interpretation, mathematical logic used to represent the truth or false state of statements. Digital electrons, 1 equals to high voltage current flow, 0 equals to low voltage no current. Basic operations of Boolean algebra. First one is AND operation. The AND operation is a logical operation in Boolean algebra. It outputs true only if both inputs are true. In other cases, the outputs are 0. Second one, OR operation. The OR operation is a logical operation in Boolean algebra. It outputs 1 if at least one input is 1. The outputs is 0 only if all inputs are 0. Third one is NOT operation. The NOT operation is a unary operation, works on the signal input. It inverts the value of a binary variable. If the input is 1, the output will be 0. If the input is 0, the output will be 1. Meaning of inversion. The NOT operation reverse or inverts the value of a binary variable. If a equals to 1, a dash will be 0. If a equals to 0, a dash will be 1. Truth table first. Definition. A truth table is a tabular method used to represent the outcomes of a Boolean function or logical operations for all possible input values. It lists every possible combination of input values and shows the corresponding outputs. Purpose of a truth table. To analyze and understand how logical expressions or circuit behaves. To provide a systematic way of showing results of Boolean operations like and, or, not, etc. To verify logical equivalence between two Boolean expressions. It helps in simplifying Boolean expressions and designing digital circuits. Example truth table for the basic operations and, or, and not. And table is basically multiplication of two inputs. If one in two both inputs are 0, it leads to 0. If one input is 0 and another input is 1, 0 multiplies to 1 equals to 0. One first input is 1 and second input is 0 is also equal to 0. When both the inputs are 1, it leads to 1. Second one is OR gate. OR gate is basically addition of both inputs. 0 plus 0 equals to 0. Second input and first input both are 1 equals to 1. 0 plus 1 equals to 1, 1 plus 0 equals to 1. NOT gate is NOT gate is based on the 0 plus 0 equals to 0 or 0 plus 1 equals to 0, 1 plus 0 equals to 1 and 1 plus 1 equals to 1. Properties of Boolean algebra. First one is commutative law. In commutative law tells us the order of variables does not matter. Second one is associative law. Associative law tells us the grouping of variables does not affect the result. Third one is distributive law. Distributive law tells us the AND gate distributes over OR. and OR gate distributes over AND. Identity law. Identity law tells us adding 0 or multiplying by 1 does not change the value. Null distribution law. Null distribution law tells us the adding 1 gives 1, multiplying by 0 gives 0. Sixth one is absorption law. A term absorbs part from itself in we can see in the above expressions. De Morgan's theorem useful for the simplification and circuit designs. Important value. The important law states that the Boolean variable ordered and added with itself results in the same variable. Involution law. The involution law in Boolean algebra states that double negation of the variable else the original variable itself. Tenth one, consensus theorem. Applications of Boolean algebra. First one is digital electrons and logical circuits. Second one is computer sciences. Third one is mathematical logics. Fourth one is communication systems. Fifth one is everyday applications. Digital electronics and logical circuits. Design and simplification of logical gates used in building of microprocessors, memory units, and control circuits reduces the hardware and cost and improves the circuit efficiency. Computer sciences, programming logic, algorithms, database, memory information, mathematical logic used to represent the propositions and test validity of statements. Helps in construction, truth tables, and proofs connected to set theory. Communication systems, errors detected, and co-reaction codes. Digital data transformation used Boolean logic to detect and fix errors. Everyday applications, smartphones, calculators, and computers works entirely on Boolean operations, su- such filters, online shopping filter, size M and color black. Conclusion. Boolean algebra is the foundation of modern digital technology. It simplifies the complex logical problems into clear and manageable steps. From logical circuits to computer algorithms, it is the hidden language that powers our digital world. Its concepts are deeply connected with mathematics, logical electronics, and computer sciences. Summary of the seminar. Definition: a Boolean algebra conclusion in the final simplified form of a Boolean expression is used logical laws and identities. Purpose: to reduce the complexity, optimize logical circuits, and improve effectiveness in the digital system design based on the binary values. Boolean algebra operations only with two values, 1 and 0. Uses of logical operations. First one is AND. It is denoted with point. The second one is OR. It is denoted with plus. Third one is NOT. It is denoted with overline. These are the fundamental operations used in the simplification. Simplification benefits. Fewer logical gates needed, reduces the power consumption, faster the processing time, low cost in the circuit designing. Boolean algebra uses the key laws and theorems. Simplification are performed using rules such as first one is identity law, second one is null law, third one is important law, fourth one is commutative law, fifth one is involution law, sixth one is distributive law, seventh one is De Morgan's theorem, eighth one is absorption law, ninth one is consensus theorem. Expression versus conclusion. Expression means the original the original logical equation. Conclusion means the final minimized result. Boolean algebra can be proven with truth tables. Boolean conclusions can be verified for the correctness using truth tables by comparing the original and simplified expression. Boolean algebra applies to logical circuit designs. Each Boolean expression corresponds to a logical circuit. This simplified conclusion helps create a more effect to the circuit layout common in computing and electronics, computer processors, digital systems, programmable logical devices, microcontrollers. Boolean algebra useful in problem solving, proving logical equivalence, debugging digital logics, designing control systems.